Now, another problem I see showing up a lot with these KD problems is how much is removed on subsequent separations. And this is going to require a little bit of abstract reasoning. What we want to look at is the percentage that is removed with each extraction. So we've got our KD, and it's going to be the grams in the organic phase times the volume of the aqueous phase divided by the grams of the aqueous phase times the volume of the organic phase. And again, we have the relationship that the total equals the grams of the organic plus the grams of the aqueous. So what would be far more practical to work with here is a percentage. So what percentage remains in the organic phase versus what percentage remains in the aqueous. And to do this, we're going to divide by the total. So we get grams, we use T for total. So this represents the percentage. We multiply by 100 in the organic phase, and this is the percentage in the aqueous phase. And again, we can rearrange this. Let's say we want to figure out how much remains and how much is removed from the aqueous phase. Gram aqueous over gram total equals 1 minus G0 over GT. Now, we are going to have to do a little bit of rearranging here, but what we'll get is that, let's say we're trying to figure out how much is removed from the aqueous phase. We need to solve for G0. G0 equals G total minus G aqueous. We get, if we substitute in, G total minus G aqueous all over G aqueous, V aqueous over V organic. And yet I realize this is like a lot of math I'm going through really fast, but play the video on like half speed. Hopefully that'll help. So if we simplify this ratio, we get GT over GA minus 1, volume of the aqueous phase over volume of the organic phase. And let's rearrange. So we're going to take this, carry it over. We're going to KD. We switch to red to make it a little bit obvious, make it a little bit easier to see what's going on. So KD, volume of the organic phase, volume of the aqueous phase, equals GT over GA minus 1. We bring that over. KA over V, volume of the organic phase, KD. The volume of the aqueous phase plus 1 equals the total over the aqueous phase. And if we want to solve for the percentage that remains, GA over GT is 1 over KD, V0, VA plus 1 over the whole thing. So this is the percentage of the aqueous phase that remains relative to the total amount. And this is actually a very useful ratio. This is the percentage left, assuming we added the compound we're interested in to the aqueous phase first. Now, to figure out how much remains with successive removal, all we have to do is take the total times this ratio GA over G total, which in this case is 1 over Ka, the organic, the aqueous, plus 1 to the minus 1. Each time we do this extraction, we get this percentage remaining in the aqueous phase. So if we do N extractions, we're going to have that percentage remaining. And so if we just do the whole thing raised to the n power, we get that the total moles, total mass, times this ratio raised to the number of separations will give us the grams that remain in the aqueous phase after that many separations. So yes, I realize this is kind of a lot to take in. You may need to watch this video a lot, but practically what this does is it gives us a useful solution. If we know the partition coefficient KD, we know the volumes of the organic in the aqueous phase. If we want to know how much is assuming it all starts out in the aqueous phase, how much remains in the aqueous phase after extraction, we just take the total moles times this ratio. KAV0 over volume of the organic plus divided by the volume over aqueous plus 1 over that whole thing, and we keep doing that for each extraction where we keep those ratios the same. So hopefully this kind of helps you out with these types of problems, but again, This is what meant to kind of create a simple way to figure out how much remains in the aqueous phase after subsequent removals.